I'm Duncan McLeod, and this is TechCentral. My next guest is an expert in TV white spaces spectrum. His name is Keith Pitout, and he's Chief Technology Officer at a company called Indigo Broadband. Keith, it's good to see you. Thanks for making the time today.
Good day, Duncan, and most welcome. Look forward to it, and very exciting times ahead.
So, the reason I'm really keen to talk to you today is that the communications regulator, Icasa, has just licensed three companies under the COVID-19 Spectrum Relief Program to provide TV white spaces projects. Uh, let's start with a definition. What is TV white spaces and why is it important?
Okay. TV white spaces to the common person out there is the channels that are not being used by terrestrial analog TV broadcasters. And we all know the migration, but just to give it in simple terms, that's your SABC 123 and ETV channels. So out of that spectrum that they use, there are a lot of spare white channels not being used. And these are, because of the low frequency, very suitable for a good radio transmission in non-line of sight areas and areas where you have trees and that sort of type of environment.
Okay, so it's low frequency. We're talking the VHF and UHF bands that TV broadcasters use.
Correct. We're talking between 470 and 694, according to Icasa regulations. In Europe, it goes up to 790. But we are within the European standards, but we follow from 470 to 694 megahertz.
And what is it about these particular frequencies that makes it good for this type of application? Do the length of the waves penetrate more easily through buildings and travel better around corners?
Correct. It's particularly suitable. It's got longer range than your higher frequencies of your typical Wi-Fi applications. And it penetrates through foliage, trees, buildings, and you can have what they call near line of sight or non-line of sight.
Mm-hmm.
There's all the other technologies require a direct line of sight to function correctly.
No, right now we know you've alluded to the fact that we are way behind with our digital migration project, and Centec, the state-owned broadcast signal distributor, rather, has been running both analog and digital signals for a period of years now through this period of what they call dual illumination, where both analog and digital broadcasts coexist. Given that the airwaves are being so heavily utilized because both technologies are currently in being used in South Africa, is there a lot of spectrum still available to do white spaces projects?
Yes, there is. Only the lower part, the analog, is being occupied, and particularly in your rural areas, only 4 of the 28 channels available in that spectrum are normally used for your SABC 123 and ETV. So you're sitting with 24 8 megahertz channels available for usage in that area. And that has been the attraction and what has arrived originally for this TV white space, which started in the Scottish Islands to use this low spectrum because of the propagation characteristics across water and foliage.
Yeah, yeah. And you can't use this exactly the same channels that the broadcasters are using, because I presume there would then be some sort of interference.
No, part of TV white space is TV white space mobile broadband or broadband operators are classified as secondary operators within the spectrum.
Mm-hmm.
Your TV broadcaster is the primary operator, so they have preference over the channels being used, and the TV white space operators will use the channels that are not being used by the broadcaster.
All right. Before we get into some of the details about what's happening here in South Africa, Keith, just tell me a bit about Indigo Broadband and what it is you guys do.
Indigo Broadband originally came from, I was involved in Kenya with Indigo Telecom, and we did the first pilot TV whitespace project with Microsoft and Mawingu in Kenya. And I came back to South Africa with the hope that we'll kickstart this. That's back in end of 2014. But regulatory has taken some time. So, but Indigo has transformed. We pioneered very much and were involved in contributing to the white papers on TV whitespace for a passion for rural connectivity. At the moment, Indigo are the master distributors for Carlson Wireless for Africa.
Mm-hmm.
And we formed a partnership with them and pioneered their type approval process in South Africa. And but we not only we look at various solutions, and TV white space plus other technology combined to help establish more connectivity into the far-reaching areas. So that is our mission.
Mm-hmm. Is this technology particularly suited for rural deployments, or is it something that can be deployed in the cities as well?
It can be deployed in the cities. Your bigger problem in the cities is you've got a lot more TV channels being utilized. And some of our experience, we've done a test over the last year, basically fine-tuning and tweaking and integrating. But and that has been in the Johannesburg CBD, and we have found a lot of spurious transmissions in the spectrum. So it's not as clean as one would expect it to be. And I don't think sometimes, the regulator is updated on unknown users. So it can be used, and we've used it, and we've had success. But you have to be pretty smart and scan the spectrum yourself with an analyzer to see if there are unknowns besides the channels that are not allowed to be used due to broadcasters. Because as we know, Centec has various repeaters. So you've got multiple channels being repeated in the area, and it creates a bit of a noisy RF floor level. But it can be used, yes. But preferably out into the rural areas is where it's a lot quieter in this TV spectrum.
Yeah, and a lot less illegal use of the spectrum. It sounds like it might be going on.
No comment.
So, Keith, there have been several trials in South Africa. I can count 3. There may have been more. And some major international technology companies have been involved in those trials, including Google and Microsoft.
Yeah, Microsoft predominantly, yes.
Yeah, Microsoft, I think, was involved in the one outside Polokwane in Limpopo, and Google was involved in one near Cape Town. What was learned in those trials, and particularly in the application of TV white spaces technology in South African context?
Well, I think the interesting one was very much the Cape Town one in Tygerberg, where it even allowed the regulators, both American FCC and ETSI, to change the rules, whereas previously you were only allowed to be 2 channels away from a TV broadcast channel, whereas it showed that the accuracy and dedication of the TV whitespace channel form allowed you to operate directly in between 2 adjacent TV channels without interference either way. So that immediately changed the whole technology or the regulatory guidelines, and opened up a lot more available channels. So you can actually operate adjacent to a TV channel. We try not to, but it is possible, depending if the TV whitespace vendor's waveform is as accurate as it should be. It should be a very square waveform, being a digital waveform, and very clean. So that is critical and part of the type approval acceptance that all vendors have to go through, and the regulator is very, very specific about passing all the ETSI standards and regulations required.
Icasa has been a bit of a pioneer in this space, hasn't it? We were one of the first countries, if I'm not mistaken, to develop final regulations around TV white spaces spectrum. Are we a bit of a pioneer here in South Africa?
We're a pioneer in terms of Africa, yes. I mean, other countries, we know UK is, I think, the original pioneer with Ofcom, and America, Singapore, Malaysia, or some of the others that are operating already, and Korea. But South Africa brought out the first technical regulations about the type and channel and the hardware and the design. That was March 2018. So that was published, and a lot of the other regulators are observing and keeping close eye on what Icasa is doing. And currently, we are finally awaiting the release of the framework regulations for the geolocation spectral database.
Okay, well, I want to talk a bit about that later in the podcast, but how big do you think the addressable market is here, and who are the consumers who are going to be using TV white spaces at the end of the day?
Well, the addressable market, if one looked at a study that a good friend of mine, David Johnson, did for the Wireless Access Providers Association, indicating what frequencies are suitable in what areas. And I'll even go back to my earlier days when I did the DECT program for Telkom in Eastern Cape and KwaZulu-Natal.
Oh, interesting.
Long ago.
Interesting.
that was covering all the villages in the Eastern Cape and KwaZulu-Natal, and that is the target, and any other rural community in places around the country that you can, because of this propagation, cover those lower densities. And the nice thing about white space is the power consumption is very low, so you can operate off-grid with solar kits, both in your domestic and your base stations. So it's a very efficient form of communication, very simple, a plug-and-play type approach, management a bit difficult, and it's a typical layer 2 network. So no complicated network infrastructure. It's almost like a wireless broadband LAN or WLAN.
I was gonna ask how this compares to cellular technology. I presume the components in building this network are significantly cheaper.
They still, the components are definitely cheaper. I think the big difference is you don't need a core network. It's a simple layer 2 IP network that you're connecting back to. So there's no complications and no major backhaul. You just need your billing systems, your authentication, and bandwidth management, in the backhaul. So
how is backhaul typically done? Is it through microwave connections?
It depends. It can be fiber, it can be microwave. It depends, and even satellite. We're looking at a lot of VSAT backhauls now that they become affordable, and particularly in a remote area, you can start off with a VSAT backhaul, create the demand, and if there's any backhaul operator interested, they will bring fiber or microwave. If I think back in relative to the old DEC days, there were microwave links going all the way back to a telecom exchange to every tower. So that was in 1999. So I'm going back a long way.
Yeah, interesting. So how does it work?
Huge. The potential is huge.
Potential is huge. How does it work in practice, Keith? If you roll out a TV white spaces network, let's say in the Valley of 1,000 Hills in KwaZulu-Natal, how does the end user get access to that connectivity?
Well, the end user is like any wireless 5 gig system. You'd have a consumer premises receiver, which is basically, and that has a port on it, which is an internet, typical RJ45 connection. And in most cases, you will put a Wi-Fi router or a router inside the house and provide connectivity. So your base station is then connected to your backhaul cloud. And you go back to a host that is hosting your billing system, authentication, etc. Yeah.
All right. So, but I imagine in many of these very rural areas, people would struggle to buy even an end user router, CPE equipment. Do you expect that a lot of this connectivity will be provided through, say, community centers, which happen to install some sort of Wi-Fi system, or do you think there'll be business opportunities for vendors, for I don't know, spaza shop owners, for example, to put some sort of Wi-Fi infrastructure on the roof and provide internet access to the people in the immediate area?
Definitely. There's a couple of models, and we've done extensive work with some of our partners into business modeling to make it affordable for the end user, but still a sustainable business, because at the end of the day, nothing is for free.
Yeah.
Although a lot of people are offering free Wi-Fi, it's normally sponsored. So we're looking at applying what I call front-end monetizing, whether it's sponsored data, and there's a couple of people who've spoken about it. Some sites are obviously 0 rated, but or reverse rated. So if you're looking at sponsors and they're paying for content delivery nowadays more than actually developing a broadband network. So you partner with a lot of these, but a lot of them either are landing pages with adverts in. We know all the other social media people are doing that all the time, and there is a lot that want to sponsor, whether it's health, whether it's medical, whether it's agricultural, etc. So all that sphere of medical, agricultural, learning, and finance, those are the 4 spheres that really mean a lot to the rural communities. And there are a lot of applications going now, but the biggest missing part is connectivity, and that is critical. Without it, all these applications around, without connectivity, you can't do anything.
What sort of speeds can you deliver through a TV white spaces network?
Good question. A lot of people have made a lot of noise about their high speeds and high volumes, but it's a matter of physics. and with an 8 megahertz channel at those lower frequencies. What we found, and with Carlson, we're talking up to 30 megabits per second per link, in other words, between your base station and CPE.
Right.
Some vendors are talking about channel bonding, which is coming. We will apply it later, where they compile 2 channels or 3 channels together. And that then gives you 3 times the 30 megabits per second. With Carlson, we have a 3-sectored radio or 3 radio base station. So we're operating in 3 sectors with 120 degrees. So that gives you a base station throughput of, call it 92 megabits per second. But that also depends, clearly on your quality of signal, your RSSI levels, etc. And the further out you go, also, the slower the speed will get. My experience when we worked in Kenya, around about 15 kilometers, we were getting 4 megabits per second.
Wow, that's pretty good. That's pretty good.
And that was in the old Generation 2 product.
Yeah.
Yes, so there's and the interesting thing is it's not symmetrical data, it's asymmetrical. And it's because of your cognitive radio, it's smart packaged. In other words, it determines which is the flow of traffic, which is very good because it's very suitable for uplink traffic or video traffic, two-way conversations. So it's a different data, and it's a lot more smart. The traffic is managed properly between your client and your base station. So you've got aggregated traffic, and I think your efficiency, then your throughput efficiency, is a lot higher than normal standard radio or Wi-Fi transmission.
Yeah. Now we've seen the mobile operators rolling out networks quite aggressively countrywide. I think both Vodacom and MTN are talking about 95% population coverage now with 4G LTE. But there are obviously affordability issues, particularly in the rural areas. The promise, as I understand it, of TV white spaces spectrum is that you're going to be able to bring down the cost of that access. What sort of numbers are we talking about here? How cheap can this bandwidth actually get to the end user?
That's a good question, and I think a lot of people, pretty much aligned with how long is a piece of string. But at the end of the day, affordability, what we've picked up in a lot of areas, goes as far down as to either using uncapped, or if you're looking at gigabytes, offering a fair package, because it depends on what the end user can afford. And in a lot of cases, it's on an average of 100 odd rand or 150 rand a month most is what they're spending on mobile connection at the moment. But that's what we're working on, the models, and I think there's going to be a bit of trial and error and tweaking of the models to make sure that it's affordable. Some people have in the past, like the one network, and they've done it before, where it's community owned, but they're still buying and selling, but it depends on how you manage it. And of course, the interesting factor that's coming into creating mesh networks and incentives using blockchain, and that's starting to appear into the field at the moment in blockchain managed mesh networks in the community. So that looks exciting, but it's all ways of means of creating inner trading and peer-to-peer trading more than anything, and then generating, as I said, the front end monetizing of that affordability. So it's not free. I think the more you make it free, it creates a sense of entitlement. And I've learned from some communities that rather charge a nominal amount, a small amount nominal, that is understanding that it's becoming part of a cost or something to pay for, but make it definitely attractive and affordable. And obviously provide your zero-rated sites that are convenient, whether it's learning, etc. But those zero-rated are then sponsored by the content providers of those zero-rated sites.
I was interested in what you said about...
If that answers the question. As I said, it's a difficult one to judge at the moment, because a lot of people are saying, well, I'll give it for free. And somebody somewhere along the line, and we've seen it, a lot of WISPs go out, or they borderline cases and they break even. But you've got to make it sustainable, whether you're looking at a franchised model or for your WISPs or your spaza shops out there, and you're working on a shared revenue basis. There's a lot of thought gone into it. But we're trying to actually figure out, and it'll depend on the communities, what you can apply and afford and how we can work it. So it's not final yet, but it's looking very attractive to make it affordable to the community, but a sustainable business all around, and not, I mean, your margins are going to be very limited.
Are there other countries that look similar to South Africa that have deployed TV white spaces technology that we can learn from, or are we going to be pretty much a pioneer in this area and rolling out into poor rural communities?
I think at the moment, in Africa, very few. I know Malawi's got a network, and Ghana's got some trials. Botswana's got Namibia, but very few are fully commercial because of regulatory issues and the spectrum database that has taken a while to develop. And our dear friends at CSIR have developed ours, which is particular to our regulations because they've got to block out the channels that are being used by the satellite telescopes. So there's various limitations. Those are the only limitations, but each country has its own. So yes, and I know Tanzania are pioneering a lot of the regulators, and I've seen activity in Ghana, Nigeria, Kenya by the regulators. Kenya's pushing it now; they draft papers out. So they're all realizing that we need to get on this bandwagon, because I think at the moment what COVID has really shown to us is that connectivity is so badly required to enlighten, to inform, to get to people out in the rural areas in a lot of factors. And we've all realized at home the consumption of data has just shot up because we're all communicating. So yeah, it's definitely following. There's a lot of interest, and we're picking it up because of our involvement with the regulatory and gone through white papers and discussions, etc., and our close association with the CSIR to get a working geolocation database.
Mm-hmm. Well, let's talk about that database and how it works. I understand there's two types, and I forget the technical terminology, but there's two ways of doing this. One is through sort of a manual programming of the spectrum in a particular area, and the other is through some sort of active system that monitors for interference and finds the best, the clearest piece of spectrum to use. Am I describing that correctly? I'm probably butchering it slightly.
Yeah, very much so. The only thing at the moment that I haven't seen fully available is a fully dynamic spectrum management, because then you need spectrum sensors and that sort of stuff around. What is happening currently is the database has its primary database, which is owned by Icasa, which is updated by Centec, and that gives you all the TV channels in use in a particular geographic area. So and part of the regulations is your base station has an active GPS in it.
All right.
And when you connect to this database via the internet URL, that GPS coordinates is transmitted to the database, which tells you the location. And if approved to operate, it then registers with the database and requests spectrum.
Mm-hmm.
So you on your system, you can either allow it to manually or allow it to automatically just allocate channels that are required for the links to the CPE, or you can manually select the channels. And what we found in the urban area where there was a lot of RF noise unexpectedly, we manually selected the channels to avoid, because at the moment there isn't this censoring to say, hang on, I've got interference or there's a lot of noise here, go and find another channel. That will come in time, but your database and all your areas need to have spectrum sensors active to be able to report a noise. The technology, the equipment that Carlson has got can sense that and pick up noisy levels, but it doesn't. The database can't automatically say, all right, choose another channel.
Mm-hmm.
So that is a development which will materialize, because I think it's sort of early stages at this stage to start walking before we can run, but definitely on the cards to start evolving that into a really dynamic spectrum allocation, which is what DSA stands for.
Mm-hmm.
So it's to have that dynamic that you don't have to worry about it. It manages itself. And the equipment has the intelligence to do that. It's just having the input to allow it to do that and then relate to the database. So they haven't developed it yet. I'm not sure whether in UK or anywhere else it is. I haven't bothered to look, but it'll be on the cards, I'm sure, here when you get a lot more people into it. And obviously it takes a bit of financial resources to develop that.
Mm-hmm. So the interesting news in the announcement from Icasa last week that the mobile operators are getting additional spectrum to cope with the growing demand during the COVID-19 lockdown and beyond was the announcement that they have licensed as part of this process 3 TV white spaces operators to go ahead with projects. And I know you're working with at least one of them.
Yes.
I know you probably can't speak on their behalf, but are we talking significant projects here?
We are talking significant projects, in particular 2 that we know of. The other 2 operators, and I just want to say that the only reason there's 3 approved is people weren't aware that the regulations that came out by Icasa on the 6th of April for applications for the COVID spectrum releases, most of these WISPs or ISPs interested in white space thought it was only for mobile operators.
Right.
So they applied via the email address to Icasa for type approval, which was the 3 of them. Obviously, we know, and we work with one, Mariah Telecom Solutions, who have been partners with us through this whole, they work together with us very much as our implementation partner. We're not an operator, we're a technology partner. So they have really gained a lot of experience of installation and learning curves and the do's and don'ts. And they at the moment are trained on the Carlson product and understand what to do and what not to do. However, there is the door open that others can still apply using the email address provided by Icasa to operate TV white space. And they will then get given approval, and they then, with that approval, can go to the CSIR and apply for registration on the geolocation database. And at the moment, that part of that registration will only allow them to choose one of 2 vendors currently approved by Icasa for hardware and systems. So although there's only 3 that were announced, those were the only 3 that actually applied, mainly because we knew what was happening and the word got out. But there's a whole list of others that have expressed an interest in the technology that they can still go and apply and register as long as they have an ECNS license. So they need to be a licensed ECNS operator and email Icasa, and it will be fast-tracked to consider and approve their application.
All right, so it's open for business. The regulations are in force. Companies interested in building these networks can apply for licenses and can start doing so immediately.
Yeah, it'll give a 4-month period, or as long as COVID exists, and thereafter, after that, the operators will apply to Icasa to follow the normal commercial process, which regulations are going to be out very soon.
Okay, so you can't actually apply directly for a commercial license now. You'd have to do it under the COVID-19 regulations.
Correct.
I see. Okay. All right. Well, it sounds quite exciting. Who do you think will be the main companies applying for these licenses? Do you think it'll typically be the WISPs?
It's targeted for the WISPs. You know, the intention originally by the regulator is to support WISPs in establishing community or smaller networks in areas, and it's not really for the bigger players. I don't think they're more interested in the other spectrum for LTE, etc. But it's encouraging also, and it's time that one talks with the main MNO players about data offloading and looking at supporting the communities in providing a data offload feature, which is attractive because then people can use their mobile data within a Wi-Fi environment. And I seriously think, I know some of them have mentioned considering data offloads, and that will also stimulate your local economies and local communities and local networks, provide them with a source of stimulus as far as data usage is concerned.
Yeah.
So it's something that one will approach, but I think it'll go that way hopefully in the future. One country that did it a couple of years ago was Zimbabwe. Okay. And they created Wi-Fi hotspots all over instead of building out a 4G network. Interesting.
We've obviously got the USASA, I can never remember what it stands for, the underserviced area.
Okay, yes,
agency. I forget what the full name is. It's quite a mouthful. Yeah. But they administer something called the Universal Service Access Fund.
Good question.
And last time I looked, there was probably about R1 billion or more sitting in that Universal Service Access Fund. It would strike me that these sort of rural TV white spaces projects are ideal for directing some of that money towards.
Perfect. Actually, very much so. And one country that has done that is Ghana. And Ghana has used the Universal Service Fund very much for supporting not only TV white spaces, but even the MNOs to build the infrastructure, which is your majority of your costs. So your towers and some of that physical infrastructure. And yes, a question was asked to me not so long ago, and I've also raised the question all over. What's happened to this Universal Service Fund? And now's the time that they can get in and support that infrastructure, because the capex costs to build the network is where it lies. So build the infrastructure and maybe then create almost like an open access network, or some operators just provide a carrier and then create your agency or franchise type WISPs, which is a perfect model to run, because then they're not carrying the major overhead of running the network. It's almost like an MVNO, but a virtual ISP.
How do you see this developing, Keith, before I let you go, over the coming years? Do you think there'll be pockets where WISPs and other companies build out TV white spaces network infrastructure, and it'll slowly spread across the country, and once it reaches a certain size, these networks are going to start interconnecting with each other? How do you see the next few years playing out?
Yeah, that's a good question. It possibly will do, but I really think the support of community-based networks be really supported more than trying to conglomerate them all, because that maintains the ecosystem within the communities and supports business and peer-to-peer trading, which is very prevalent in communities. And I've seen it when I've worked all over Africa, that in your very rural areas, your peer-to-peer trading, whether it's goats, vegetables, fruit, or you name it, it's the old barter system. And that's what I said, if you bring in blockchain type technologies for peer-to-peer trading, whether using blockchain currency or whatever it is, will, I think, evolve and develop within these communities and keep the rural broadband networks going. But I would like to see it, and like to see people prosper that way instead of being taken over by larger conglomerates. Let the conglomerates support them, because it's a win-win situation.
Well, hopefully we're going to have some of these operators on the show soon. Hopefully we'll get Mariah on as well to talk about what their initiatives are. So I look forward to that. Sorry,
I'm sure
Keith.
You'll get them very soon. No, you'll get them very soon. And yeah, if anybody is interested, you can leave our email address or whatever, or look at our website of how to go. We will help people. We're there to help. And as I said, we're a technology partner. We're not an operator. And we want to help people with the knowledge we've learned and advice on how to get set up and get going. And we've got a very good relationship with the processors, Icasa and CSR.
What's your website, Keith?
It's www.indigobroadband.co.za.
There we go. You can visit that website to learn more about TV white spaces spectrum and what's happening in this country.
And you can email us also at info@indigobroadband.co.za.
There we go. Keith Pitout is Chief Technology Officer at Indigo Broadband. Thanks so much for your insights.
Thanks very much, Duncan, and appreciate it. Let's hope this is a complete watershed for the rural communities.